We are looking at SAS 6 today, Student Activity Sheet 6, High-Speed Internet. So the setup is that you're making a network, internet network among some offices, and we're trying to be efficient here. So this starts a slightly different portion of our first unit on networks. We're still doing graphs. We'll still have vertices and edges, but we're looking at efficiency and networks now rather than just graphs. It's a slightly different tack that we will be using for this next several lessons. And I will just give you a heads up. Starting on Thursday, we'll be doing a project. We'll have Thursday, Friday, and Monday. You'll have to work on this project, and it'd be nice if you have an empty cereal box for your project. Since you are remote, you're going to be working on your own. But some people choose to do it on their own at school too, so that's fine. It's certainly not too much to handle, but it's nice if you have a cereal box. You don't have to have a cereal box, but if you have an empty cereal box, it might come in handy. Okay, so here we go. Okay, we're looking at Student Activity Sheet 6, High-Speed Internet. Your company must run Ethernet cables to 5 different offices so that all 5 offices have high-speed internet access. For each computer to be on the office network, there must be a way to get from each computer to the other computers by following the cable. So number one here says one worker proposed running cable between the 5 offices as illustrated in the following diagram. The vertices represent the offices, so we have 5 offices here. The edges represent segments of cable. So questions here are, the first 2, how many lengths of cable edges are used, and explain why this is an inefficient way to run the cable. All right, why is this inefficient? And then number 2, design a more efficient network and indicate how many lengths of cable are used. Okay, so I'm going to pause the video and let you answer this. You can explain your design and how many lengths of cable. Alright, since you're on your own, you're not going to be able to compare your efficient network with others in the class. But what you should have gotten is that you should only need 4 lengths of cable to be efficient. The whole idea is to connect all the offices together. All you need is 4 lengths of cable instead of the 8 lengths of cable that is in the design. All right? And probably, there's a lot of different possible lengths you can make. Different designs you can make with 4 lengths of cable. So probably, as far as part B goes here, did everyone's network have the same shape? Probably not going to have the same shape. So number 4, a cycle in a graph is a path that starts and ends at the same vertex and does not use any edge more than once. Alright, so if we can start and end at the same place, not use any edge more than once, we call that a cycle. So identify 2 cycles in the graph from question 1. So I'm going to label these points. A, B, we'll call this one in the middle C, D, and E. So find 2 cycles, okay? Just to make sure we're on the same page here, let's talk just a little bit more about cycles. So like ABC would be a cycle, okay? Because you could start at A, go to B, go to C, and back to A again. Another one would be like ABED. All right, that's a cycle because you could start at A and go to B, go to E, and go to D, and back to A. That would be a cycle. So any of these closed figures like this, a closed loop, we call that a cycle. Okay? I hope that's clear. And then look at your network that you had in question 2 and see if it has any cycles. What does the existence of cycles tell you about the efficiency of a network? Okay. So what does the existence of cycles tell you about the efficiency of a network? All right, number 5, describe how a cycle is similar to an Euler circuit. What do they have in common there? Number 6, write a set of step-by-step instructions to form an algorithm for converting an inefficient network into an efficient network. Have another student apply your algorithm to the following inefficient network. Indicate the number of edges in the final efficient network. Well, since you don't have another student, so just do this yourself. Apply your algorithm to this network on number 7. Indicate the number of edges in the final, so how many edges you're going to have at the end. And tell me what the edges are too. So the whole idea here is that if in an efficient network, you should not have any cycles. So your step-by-step instructions should look something like this. Step 1, check network for cycles. Number 2, if a cycle exists, remove an edge from that cycle. Number 3 says repeat 1 and 2 until no cycles exist. So now use this algorithm to try to make this into an efficient network. Tell me how many edges you'll have left and which edges you will have left. And there's more than one way to do this. So do your best with that. So a couple of these questions I'm going to put as an assignment for you to fill in. So look for that and give me some answers, give me some good answers, put some thought into it. And I hope you understood this okay. Let me know if you have any questions. Okay? Hope you're doing well. We'll talk to you later. Bye-bye.